According to the CDC, in 2019, approximately 39% of US adults reported experiencing back pain of some sort, and this issue becomes more prevalent as we age. Back pain can make the simplest of tasks once to dread. In this video, I hope to present a solution to this problem, which will allow people with back pain to effortlessly do their laundry. And in the process, I hope to show you how to manufacture a few of these essential components. This is the accessible dryer stand. It serves to elevate the drum of the dryer to a point that alleviates bending at the waist. Most dryer stands currently on the market also do this, and they offer a storage area underneath, just like this design, but they fail to address the accessibility to that storage area in the same way they do the drum of the dryer. This prototype experiments with using a scissor lift to elevate that storage area to make it more accessible for the user. In this video, various manufacturing techniques will be used that all require different safety precautions. When a process requires a certain precaution, it will be in the bottom right hand of the corner with its respective icon. Now on to the manufacturing.
The first component we'll be looking at is the frame. The first part of this process is determining what cuts should be made on what board. I use OptiCutter to find the optimum cutting sequence to minimize wasted material. Using this cut list, I measured the cuts needed, marking them on the board before every cut. I used a miter saw to make these cuts because this is what I had on hand, but a table saw would have worked much better in this scenario. Due to the size of the stock material, I had professional board holder and assisting electrical engineer, Benny Ling, support the board on the other side. After all the necessary cuts for the build were made, I set up for the frame side assembly build. I designed these side assemblies to be interchangeable to reduce confusion and streamline the final assembly process. With the sides completed, I could add the supports to finalize the frame. Due to budgeting and time constraints, wood was used for this frame, though in future prototypes, using extruded aluminum would serve better in the assembly process, as they can be cut similar to wood planks but allow for greater strength, lighter weight, and more precise placement. The next component is the lift axle. This was cut down to 12.5 inches from a low-carbon 1-inch square bar. Once the size, the center drill was used to start the 5 holes that would be drilled onto the face that would mate with the lead screw nut. These holes were made using the speeds and feeds chart for the low-carbon steel and the drill bit used. Once the face was milled, the axle holes needed to be drilled. Due to the size of the stock, this had to be done on a lathe. Finally, all the holes that mate with bolts were tapped by hand using plenty of tapping fluid and torquing the tap back and forth to ensure clean threads. The last component displayed in this video is the plastic sheeting that will lie atop the lift. This was made from 1/8 inch thick, high-density polyethylene. To cut this plastic to size, it was necessary to score it and then break it. Using my saw as a straight edge, I ran across the surface with a box cutter until it was deep enough for the straight edge to be of no use. From here, I could simply use my hands to bend off the excess material. After doing this for 4 of these sheets, they were then ready to be plastic welded together. As you can see, this process is similar to TIG welding, where there is a fill rod, the scrap from before, and a welding iron. Heating the fill rod while heating up the sheets was necessary to properly adhere the plastics together in a timely manner, getting both the rod and the sheets plastic to the melt temperature. This was a very time-consuming process, so only the first weld is shown here. Here's the final functionality of the prototype, which was sped up quite a bit. In future iterations, the motor should be upgraded to reduce the lift time. With that, thanks for watching.